Hello, this is Mrs. Carnahan. So I promise this video is going to be shorter than the last one. So in the last one, we talked about SOHCAHTOA and solving for sides and right triangles using these trig functions and trig ratios. So we're going to talk today about how to solve for angle measures using the same trig ratios. So we're still going to use sine, cosine, tangent. The ratios are still going to be set up the same, but now instead what we're solving for is the angle measure instead of a side length. Okay? So when we use these functions to solve for angles, we use what we call the inverse. Now if you think back to Algebra 1, when we had a function f of x, if you find the inverse of the function, we use the inverse of f of x, which is like the -1 symbol. So when we talk about these inverse sine, cosine, tangent, we're going to have that little -1. That doesn't mean anything other than telling you it's the inverse. Okay? So for sine, the inverse of sine, what I'm going to do is instead I'm solving for the angle. So what's going to go next to sine is the ratio. So with sine, it was opposite side over the hypotenuse. So in this one, we're going to be given those, the opposite and hypotenuse side, and what we're going to be solving for is the angle. Now I'm going to use theta again, so it's that, looks like an O with a line through it. That's theta. That's just a symbol for the angle measure. So it's just an angle, and it's just a variable. Okay, so it's just what I'm going to be solving for. Okay, so I'll be given the opposite and hypotenuse sides, and then I use the inverse to solve for the angle. Now it's going to work the same for cosine and tangent. So I'm still doing adjacent over hypotenuse for cosine, but again I'll have numbers here instead of a variable, and when I plug that in my calculator, that will give me the angle measure. Okay, so it's just going to depend on which sides I'm given. That will tell me which function to use. So when we do the examples, again, we're still going to continue to label our triangle and then set up our ratio the same way we've been doing, but this time we're solving for the angle. And usually the angle goes with sine, cosine, tangent. So when we do the inverse, it's the opposite. Okay, and the sine, cosine, tangent goes with the ratio instead. So for tangent, it's opposite over adjacent. Okay, so still SOHCAHTOA, and I'm still going to use SOHCAHTOA, but instead of solving for sides, we're solving for angles. So the functions that we used yesterday, just regular trig functions, that helped us solve for sides. Now, when we do the inverse trig functions, that's what helps us solve for angles. Okay, so usually when I'm solving for a side, I'm usually given at least one side and one angle in the triangle. With the solving for angles, I'm given at least one side. So I'll have two or more sides given, and then I can use that to solve for the angle. Okay, so these are going to be set up the same way. We're only going to do two examples because it is very similar to the part 1 video. So we want to find angle P. So I'm going to put theta down there where angle P is. We're looking for that angle, right? So when I label the sides, I'm going to label them based on the angle I'm finding. So opposite, I don't have the opposite side, so I'm not going to end up using the opposite side. I'm given the adjacent side, and then finally the hypotenuse across from the right angle I'm also given. So notice how on this one I'm given two of the sides. If I wanted to find the third side, I would use Pythagorean theorem. But if I want to find the angle, that's where I have to use SOHCAHTOA, because I can't use Pythagorean theorem to find an angle. So when I set this up, I have the adjacent side. So the adjacent side and the hypotenuse. So if we look at SOHCAHTOA, okay, SOHCAHTOA, adjacent and hypotenuse, up here goes with cosine. Okay, so when I set up my function, I'm going to have cosine, and I'm still going to set it up the same way. I'm not going to use the inverse just yet because I want to show you what it looks like just the regular way. So cosine goes with the angle. In this case, I don't know the angle, so that's theta. And then equals the adjacent over hypotenuse, because that's adjacent over hypotenuse for cosine. Okay, so adjacent, which in this case is 13, over hypotenuse, which is 19. So notice how this time on the right side I have numbers, and on the left side I have my variable. So now after I've set it up, I'm going to reverse this, and I'm going to say theta equals, now I'm going to take the inverse cosine, so cosine with the -1, and then the ratio stays the same, 13 divided by 19. Okay, so I'm just kind of reversing the statement we set up before because my variable now is with the cosine. To solve for it, I have to take the inverse cosine. So when we do that in our calculator, okay, here is the graphing calculator app somewhere on here. Okay, I know it's over here. There it is. Oh, I can skip for now. We're going to skip. So when I take the inverse of sine, cosine, or tangent, instead of just pressing sine like that, like we did before, like see above, or cosine, or tangent, instead of clicking it right away, I have to press the second button first, and then the function, so sine, cosine, or tangent. You can do this on your phone calculator as well, or any of the calculators that have sine, cosine, tangent. So I can do the inverse, and you'll notice it has the little -1. Now on this one it was inverse cosine, so I did second cos, and then 13 divided by 19 was the ratio, and then that's going to give me the angle. Alright, so there's my angle measured, 46.8, and that's in degrees. Okay, double check your mode if you go to mode. Mine's still in degrees. Yours should be, unless it reset for some reason, it should still be in degrees. Okay, so 46.8. Now, typically we want angle measures to the nearest degree, but I'm just going to do the nearest tenth for this one because it did say tenth. I'll just leave it to the tenth. Okay, but usually for angle measures we'll do nearest degree, side lengths we'll do to the nearest tenth. Okay, let's do one more. This one says solve the right triangle. So when it says solve the right triangle, this means that you have to find all side lengths. So I'm going to make a note of that on the side. All sides and all angles. Okay, so notice here I have two side lengths. I need to find both angles because neither of them are labeled, and I need to find the third side. Well, hopefully you notice you could use Pythagorean theorem to find the third side. It makes it a little bit easier that way, so I'm actually going to do that. 7 squared plus 4 squared, just kind of review Pythagorean theorem here, equals our hypotenuse squared. You can do Pythagorean theorem. You can use SOHCAHTOA, but you'd have to find the angle first in order to find that side. So this one just will help me find that side first. When I square those and add them, I got 65. And then it is going to have us round the side length to the nearest hundredth. So when I take the square root, I'm going to plug in my calculator, square root 65. It can't be simplified anyway, so we'll just do the decimal. And I got, let's see, I got 8.06 for that side. Okay, so now solving for the angles, I'm just going to pick an angle to start with. So I'm going to solve for A first. I'm going to put my theta there. And then once I have one angle, I can easily find the other angle because I know all three add up to 180. So I'm just going to have to use SOHCAHTOA one time here. Even though it said solve the triangle, it looks like I'd have to do it multiple times. I really only have to do it once. So right now, I'm going to go based on the sides I was given. So my opposite side, and here we have the adjacent. I'm not going to use the hypotenuse because that was a decimal. I'm going to use the given sides. So when I set this up, I have opposite and adjacent, which is going to be tangent, TOA. So tangent of the angle equals opposite 4 over adjacent 7. Now, since I'm solving for the angle, I'm going to flip it so that it's the inverse tangent of 4 over 7. You'll plug that in your calculator. Remember to press the second button first, so second tan, and then 4 divided by 7, and I got about 30 degrees. I got 29.7, and it says round to the nearest degree, so I'm going to round that to 30 degrees. Okay, so that would be angle A. So I'm going to write that on the side. The measure of angle A was 30. So if I want to find the angle B, if angle A is 30, then if I take 30 plus 90, that gives me 120. If I subtract that from 180, I get 60. And hopefully you notice it is a 30, 60, 90, but we didn't use the 30, 60, 90 to solve it. And we also rounded. So it's not exactly a 30, 60, 90, but it's close. So the measure of angle B is 60 degrees. And then side AB, or what I labeled C, was the 8.06. Okay, so these would be my final answers, the 2 missing angles and the missing side. Okay, so notice I only had to use SOHCAHTOA once here. You can still use some of those other problem solving methods that we've talked about before. Okay, so again, with inverse, you press the second button. We use this when we're solving for angles instead of sides.